Welcome back, AP Calc. We will continue to approximate distances using the velocity function here. And this is part 2. So we had Juan's example in part 1, and we're going to get a little more complex here. Because I'm not going to give you a consistent velocity graph. I'm going to give you a velocity graph that is continuous, but definitely not linear, so it's not consistent. Alright, so we're going to start off with the velocity at 20 miles per hour. And then I'm going to point out some different velocities that are indicated at each whole number of hours as we go through the graph. And this is not a linear function between 0, 20, and, I suppose I should name this 0, 20. 0, 20 and 160. It's not a linear function between 160 and 280, and so on through the idea. However, we can still approximate the total distance that was covered using the same concept we did last period. Rate times time equals distance. And the rate is our velocity, so v of t, and the time is going to be just our time in hours. And then that's going to give us our total distance, so we should be pretty good. Okay, what I've done is I've taken the velocity graph and the points that were indicated on the graph, and I've created a chart. So what you will typically be given is a chart like this. And you're not asked to literally create a graph for it. I don't want you to create a graph for it. I want you to be able to utilize the graph in order to get your answer complete. However, I'm going to just talk you through what's happening on the graph part of it, because getting a picture of it inside your mind helps you make sense of the process. So, I've taken the liberty of putting the time in hours on my first row up there, as you can see, and my velocity here, 20, 60, 80, 70, 40, 50, 60, 70, 40, 30, and 0. So 10, 0. So I have 11 different time periods here for my hours, time hours values, and another 11 for my velocity as well. Alright, the first way we are going to approximate this total distance is by using what's called a left Riemann sum. Now, don't get too hung up with this word, Riemann here. Basically, it's when we draw our rectangles, and we either decide to use the left side of the rectangle or the right side of the rectangle. I know that in the past I've either given you a completely increasing function, so that the right side of the rectangle would give you an upper sum and the left side of the rectangle would give you a lower sum, or I've given you a decreasing function through the whole entire interval, and that way your left side would be your increasing, or your upper sum, and your right side would be your lower sum. However, this is going up and down and up and down and up and down. So by the time I'm done, if I use a left or a right, I'm not really sure which one's going to be bigger, which one's going to be smaller. And that's because the graph is moving up, moving down, moving up, moving down. So we're going to go a left Riemann sum with 5 subintervals of equal width. Now it just so happens that I can have equal widths because my intervals in time are equally spaced out, 1 per hour. However, Riemann sums work with unequal widths as well. So this particular example just happens to have equal widths. So I want 5 subintervals. I'm going from 0 to 10. So 10 divided by 5 is 2. So I'm going to have a subinterval here of 2 units, and a subinterval 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 of 2 units, and that's going to give me 1, 2, 3, 4, 5 units. And we've done this before. This is my delta x, which is b minus a over n. You should ring a little bit of a bell with you here someplace. So I'm looking at 10 minus 0 divided by 5, and that would be a width of my delta x, and in this case that would be delta t of 2 hours. So I want 5 subintervals. First thing we're going to do is set up 5 rectangles. So area is going to equal base times height, added with base times height, added with base times height, added with base times height, and what's that for? I need one more, base times height. So I can come over here and give you an idea of what's happening on my graph. So I'm going from 0 to 2. So I basically want to chop this and come up here at my 2. I'm going to go from 2 to 4, so I want to come up here, I'm going to put 440 on the top. Erase this so I don't get into it. And my 660. And it looks like every one of them I need to erase, huh? There. So I've taken the interval between 0 and 10, and I've chopped chopped it up into 1, 2, 3, 4, 5 subintervals, and in this case they happen to be of equal length. Okay, they don't have to be, but for this example they are. So I want to do base times height, base times height, base times height, base times height, and base times height, add them all up, and I will get an approximate total distance or area under the velocity function. Okay, it'll give me my total distance. Rate times time equals distance. Velocity, which is my height, times my time, which is my base, is going to give me distance. So I'll add up this distance, this one, and this one, and it'll give me the total distance. All right, so here we go. My base for the first thing is a 2, which I know because from 0 to 2 is a 2. And my height. If I want to use the left Riemann sum, so I want to use this left side of this interval. The left side of this interval only goes up to 20. So basically I'm only going to use this little tiny rectangle to approximate this whole thing, which seems kind of bad, but you know, in the next one, here's my interval here, and here's my left side. So I'll have a lot more up there. So sometimes I'll have not enough, sometimes I'll have extra, and it's just an approximation. Of course, the more intervals we have, the better approximation we're going to have because the less gap or overlap we have in each interval. Anyway, let's go ahead. We have a base of 2 and a height of 20. So here's my height of 20. My next subinterval has a base of 2, and I'm going to use my left side of this rectangle. So it's going to be a height of 80. So 2 times 80. The next interval is still a base of 2 because all my subintervals have the equal base of 2. And my height here will have a height of, I want to use the left side, so a height of 40. So 2 times 40. And again, my base will be a 2 for the fourth rectangle. And I have a left side and a right side for this rectangle. I'm going to use the left side and build a rectangle to approximate this area. This is a little better. See that a little over here, a little under here, so it kind of compensates. So this is a base of 2 and a height of 60. Here's my 60. And for my last rectangle, I have a base of 2 still. I'm going to use the left side. So it gives me a height of, what is that, 40 right here, 8, 40. And I'm going to notice that I have a 2 as my base in every single example here, every single rectangle. So I'm going to factor out the 2. And I'm going to have 20 plus 80 plus 40 plus 60 plus 40. I have to make sure that I have 5 subintervals. It's easy to accidentally have 6 for some reason, but make sure you have 5 exactly. Okay, so I have 20 and 80 make 100, 60 and 40 make another 100, that's 240. So I'm looking at 2 times 240, which is 480 what? 480 what? It's time multiplied by velocity. So it's hours multiplied by miles per hour. Simply going to give me total miles. And that is what I would have for a left Riemann sum of 5 subintervals of equal length. Now I use the picture to do that with you. And yet I told you at the beginning of this that I'm going to have you using the chart and not the picture. So let's just look over this information, pair it up with our chart, and see how easy those numbers can come into play to fill in your base times height. All right. The distance between 0 and 2 is 2. There's your base. Left Riemann sum means I'm either going to use this 20 or this 80. I want the number on the left. I'm going to use a 20. So 2 times 20. Right there. 2 times 20. My next interval is from the 2 to the 4, and that's a distance of 2. So my heights are either going to be a 40 or an 80, and I want the left Riemann sum, so I want the 80. So 2 times 80, and that's right here, 2 times 80. The next subinterval has a width of 2 again, between 4 and 6. Left side says use the 40, not the 60. Okay, so 2 times 40, right there for my third subinterval. My fourth subinterval, again, has a base of 2, so you're either going to use the 60 or the 40. We want the left Riemann sum, so we will use the 60, and here it is, 2 times 60. And lastly, the last subinterval has a base of 2, and I'm either going to use the 40 or the 0 for my height. I want the left side, so it's a 40, 2 times 40. And you can factor out your 2. You don't have to factor out your 2 if you don't want to. It just makes mental math a whole lot easier if you can multiply once at the end. instead of multiplying 5 times and then adding big numbers up. So this is 480 miles as our left Riemann sum. Okay. I'm going to put that number over here. First way, left Riemann sum, 480 miles. Alrighty. We're going to say the end of part 2 has come to a close.